or
Really bless you. Give you long life.
all right. Can we move on? Can
Yes,
you hear me, please?
Yes,
Okay,
Grandpa.
all right. So I'm saying that with the eosin test, the nigrosin is added, and now eosin nigrosin become very popular. All right, but the actual deal or the principle of the sin, everything is based on the eosin. The nigrosin is just coming in as a counter stain to give you a background staining to have a contrast. Okay, all right. Now let's look at the principle of, so the whole principle is about the eosin. Now I'm saying that even though you have eosin nigrosin tests, the actual staining is based on the action of eosin. And so, like I said, the nigrosin becomes a background, gives a background staining. And so this principle of the testing is what we're going to talk about, and it's based on the eosin staining itself. Now, the viability testing by the eosin staining technique can be explained on the principle of dye exclusion. Dye exclusion. And when the dye here is, what is the dye here? When I'm talking about the dye, in this scenario, what is it?
The dye is the eosin.
Fantastic. The dye is the eosin. Hey, Moses. So I finally when you high marks but I have a you're doing well. Okay. So the dye here is the eosin. And when I say excluded, you know, dyes are supposed to impart colors. Is that not it? A dye is supposed to impart color. Dyes stain because they impart their color to whatever you want them to stain. If it's a cell, then they must impart their color to that cell. All right. So once you say you are excluding it, what does it mean? That exclusion in ordinary terms, what does it mean? Exclusion means you are being prevented. I mean, it's prevented. So it means that the cell is preventing the dye from imparting its color to it. You know that to stain is to impart a color. So when you're talking about dye exclusion, what it means is that the organism or the cell is preventing the dye from imparting its color to it. All right. So how does that happen? The eosin is a supravital stain. When you say supravital stain, what is it? A supravital stain. What is it? Supravital staining. I'm sure you've heard about supravital staining and intravital staining. What is supravital stain? Hello. These are basic class 1 lab science. I'm sure you all do reticular. These days, because of automation, people even forget some of these basic tests. So you don't do reticulocyte count any longer, or you do it in your labs. Do you do it manually in your labs? Do you do retic count in your labs, or is the machine that does it for you?
The machine. Oh.
Hey, this machine age, eh? All right. Otherwise, I will take you back to hematology and the retic count, the concept of the retic count. Okay. So when I talk about supravital staining, the word vital means alive. Supra means is like
beyond or above.
Okay. Good. Very good. And then if a cell is in the if a system or a cell is within a system, it means that it's within the cell. If it comes out, anything that happens to it becomes supra. Okay. So you know that sometimes, especially in radiology. Okay, very good. Rhoda has given a good answer on the supravital stain. All right, so once the stain is going to be, well, if it's going to be used in vitro, that is in the lab, you see that in radiology, sometimes they do radiology and then they infuse certain dyes into the body, and then the dyes color certain areas so that they can take the pictures there. That becomes intra-vital because vital is alive, and then it's inside the whatever they want to, whether it's an organ or something they want to be seen. They are doing the staining within the body, so that becomes intra-vital. But if you take that system outside into a lab, anything you do in the lab is in vitro. Okay. Now,
Yes.
If you take it outside in the lab and then the cells are still alive and you are staining them while they are still alive, then that becomes supravital staining. Okay, supravital staining. Eosin is one of those. Eosin is one of those dyes. They can stain live cells. All right, they can stain live cells. So eosin is a supravital stain. So now with this concept of dye exclusion, what it means is that the cells which you saw them as dead, in quote, and they're actually not dead, they will not allow to, because you know that the cells, they also have intact plasmalemma. What is plasmalemma? What is plasmalemma? George, yes. I thought George was going to answer. That is just the cell membrane. So, all right. Rhoda again there, that's correct. So it is the cell membrane. That you remember that once the cell, so the sperm you saw as though dead, is not dead. You think that is cell membrane dead or not? Yes, if the sperm that was seen as dead, if it's actually not dead, is cell membrane dead or not?
It's not dead.
It's not dead. What is the function of the cell membrane? The cell membrane is there to prevent unnecessary things to enter into the cell. Is that not it? The cell membrane is protecting the whole structure of the cell so that it will not allow anything to come in there. So if the sperm you saw are dead and then a stain is coming to enter, what will it do? It will prevent it from entering. Okay, and that's what we call dye exclusion. It is excluding the dye. Master, I'm not dead though. Even though you saw me as I'm not dead. I'll not. My cell membrane is intact. I'll not allow you to come in. So it will exclude the dye. But those that are actually dead, what will happen is that they have no protection. The cell membrane is also damaged. They have no control. All right. So what will happen? All right, semi-permeability. Oh, Rhoda is so good. Thank you. And now all right, but speak rather than writing for me. Speak for everybody to know that you know it. All right, so the cell membrane is protecting the cell itself. So if it's not dead, it will not allow macromolecules like the stain to come and stain it. So it will exclude it, it will keep it out. So at the end of the day, you know that when you are looking at a stain material, you are looking at the color that it will impact. In this case, what do you think will be the color of the sperm, which is actually not dead, what would be its color?
Pink.
Colorless.
Colorless, Rhoda, great.
Colorless.
It will be colorless because the USC is pinkish, all right. It can only give you that pinkish appearance only when it has impacted, only when it has penetrated into the cell. Now the cell said that I'll not allow you to come in. I'll excluding you. I'm taking you out. How can the stain be pink? It will not be pink. The stain. So in USC staining, live cells are unstained. They are colorless. And that's the principle.
But Grandpa,
However, yes, sir.
But is going to stain the dead ones pink? Is that not it? Or
Yeah, the dead ones. But my first
that wasn't
was,
the question.
No, that wasn't the question. I'm saying that
sorry.
the live cells, so you saw them as dead, okay? But the cell membrane is intact. And I'm talking about the principle of dye exclusion. We are also going to talk another principle, which also has a relationship with the same thing. We are explaining the UOC staining on two principles, dye exclusion and then the membrane integrity, but they work hand in hand. Okay, so with the dye exclusion, saying that dye exclusion means it prevents the dye from entering it. That's all. So when you hear about the principle of dye exclusion, what it means is that that cell has capacity to exclude, to cause you not to come and stain you. Okay, and therefore the sperm cell will show colorless, will be colorless. You see it colorless. However, those that are dead, I mean, they have no preventive mechanism, nothing. So the stain will now just enter just like that. The stain will just enter. And so once you see the sperm staining pinkish, what it means that originally it has already died. Here you're talking about those who you saw as dead. In the first place, you saw them as all dead because they were all not moving. But the stain will not tell you that, oh, yes, we are all not moving. But as for me, I was not dead. And this one was dead. And the difference is that the one which will stain pinkish is the one which is actually dead. And the one which will be colorless, even though was presumed dead in quote, but it's actually not dead. So that's the principle of dye exclusion. And I'm hoping that you appreciate that. All right. Then there's another principle, which is also in the same line. And this is called the membrane integrity test. Membrane integrity test. And of course, membrane integrity is the same thing. The one is talking about dye exclusion, the fact that once the cell membrane is intact, it will prevent the dye from entering it. Okay, and that's the dye exclusion. Just taking the dye away. But integrity is also the same thing. Because the sperm is not dead, its cell membrane is intact. And once it is intact, its integrity is also not compromised. And so that's the membrane integrity. And once its membrane integrity is intact, what will happen? It will also not allow the eosin to stain it. So it is the same thing, except that we are using words interchangeably. Okay, so this one is the principle of the membrane integrity can be linked to the principle of dye exclusion, because it is because of the fact that the membrane is intact. That is what caused the cell the capacity to exclude you. But I'm saying so because sometimes I don't know where you may find yourself. You may find yourself also writing, doing some other courses or some exam somewhere. This thing will come up, and then you are not getting confused. It's the same test. At the end of the day, whether it is membrane integrity or dye exclusion, it will end up giving you a colorless cell, a colorless sperm, which will show that it's alive. And then whether it is cell dye exclusion or also membrane integrity, it will end up giving you a sperm which is also showing pinkish as those that are actually dead. As simple as that. Is there anybody who doesn't understand the principle? Those two principles, they are the same. They are the same. They are all explaining the same thing, except that the target is as dye exclusion, and this one's membrane integrity. That's all. Is there anybody with a challenge in understanding the principle? Right. Using stains do not stain lifespan. I think that one is well captured. But immortal and dead, that non-vital sperms will take up the eosin. That's why the dead ones become pinkish. Those dead ones are described as eosinophilic. And I'm sure when you say eosinophilic, you know, in hematology, you have the eosinophils, where eosinophils will stain pinkish. The granules that will stain pinkish, just because they will pick up the eosin. They will pick up the eosin of the stain. And anything that is picking up eosin is described as eosinophilic. Philic means loving. Eosin is the stain, pinkish stain. So eosinophilic. So once this thing comes up, you know why those terminologies are used the way they are. Then a quick look at the eosin preparation, the reagent. So you prepare 1% or 0.5% eosin Y. Eosin, you normally get a eosin Y. I'm sure you know that already. Eosin Y. Now, you prepare as 1% or 0.5%. That is all. A very simple stain. And remember, I said that you can use the eosin raw or use the eosin nigrosin. I'm taking you through the eosin 1, and then appropriate time will also take you through the eosin nigrosin. But by and large, whether eosin raw or eosin nigrosin, the principle of application is the same. They are all based on either dye exclusion method or the membrane integrity approach, whichever. The nigrosin doesn't come in. I'm saying that the nigrosin is only used as a counter stain that will stain the background, period. So let's take the eosin stain reagent. If you are preparing 1% of a reagent, what does it mean? Eosin, 1%. What does it mean? How do you understand it?
That means 1 gram in 100.
Great. Oyamanche road ajo target. Between Moses and Rhoda. All right, that's good. So 1% means 1 gram in 100 ml of water. But if this will happen if the substance is solid, okay? If it's solid, you weigh 1 gram. If you are to deal with a substance that is also a liquid, then 1% means 1 ml into 100 ml. That is also very important to note. So with this one, this is 1% means 1 gram in 100 ml. Now, I have this example here. If you have to prepare 20 ml of 0.5% eosin, how will you do it? All right. So to prepare, remember we said that it can be 1% or 0.5%. So either you prepare 1% and keep it as a stock. So anytime you want to use it, then you can use you take a part of the 1% stock and then dilute it down to 0.5. I'm sure this one you can always do it. It's just as the other day we talked about 10% potassium hydroxide. And normally in the labs, some people are able to do the skin scraping, and that will require the use of 20% potassium hydroxide. If you have 20% potassium hydroxide in your lab and you need some 10%, you don't have to prepare another 10% potassium hydroxide. Just take your 20%, part of your 20%, and then dilute it down to, and you know this class 1 formula, C1V1 is equal to C2V2. You use that one to get how much of the 20% must you take to give you your 10%. You do that calculation and you are there. The same way, if you have 1% of your using there, that becomes your stock. And if you need 0.5%, you know how much of this to take to dilute to get your 0.5. So as a test case, I just want you to be able to prepare 20 mils of 0.5% UOC. All right. So what you do is, if you have 0.5% UOC, what it means is that you weigh 0.5 grams in 100 mils. Is that not it? If you want 0.5% of UOC, 0.5% of UOC will mean 0.5 grams in 100 mils. So if I just want just 20 mils of the UOC, what it means is that my 100%, sorry, my 100 mils should be reduced to 20. What will you do to get your 20? I'm saying that 0.5% means 0.5 grams in 100 mils. You just want just 20 mils. Okay, just want 20 mils. What must you do to the 100 to get your 20?
Grandpa.
Yes, sir.
I think the 0.5 grams in 100 mils, which is a 0.5%, is so you just pick 20 mils out of it.
No.
Since that is a stock, we are not.
No, I'm just I use that one as a case scenario for you, that the test requires that you can use 1% or 0.5%. Okay. So in that case, if you're in your lab, you can prepare 1% and put it down as a stock. Okay. And next time, if you need some, you can now take some and then, but I'm saying that I want you to be able to prepare 20% of 0.5% in the lab. And just, you need the 0.5%, just 20 mils from scratch. What will you do? And I'm giving you the baseline. That 0.5% means 0.5 grams in 100 mils. So you tell yourself, okay, I only need 20 mils. Don't go. I don't want you to go and prepare the 100 mils and then pour 20 mils for me. So what will you do? The 100 mils, what must you do to get the 20 mils?
We just multiply the 0.5 by 20 and divide by 100.
No, Moses.
You divide by 5.
You divide by 5. Kingsley.
Divide by 5. So 20 will be 0.1.
So you divide the 100 by 5. You are going to get 20 there. And then the 0.5 you divide by 5, you are going to get 0.1. So what it means is that if you weigh 0.1 grams of the UOC and add 20 mils of water, then you are going to get your 0.5%. That's all. It is there already, but I just wanted you to know how you come by that. However, you see that we want somebody has something down there. What is it?
Hello, Grandpa.
Yes, sir.
Yes, to arrive at the 0.1 gram is what I was given.
Okay.
That you multiply the.
I thought that you were talking about the stock. I don't want you to go to the stock. Okay.
No, please.
All right. Okay.
All right. Okay.
That's okay. So that is that. But you see, here you said that you weigh 0.1 gram and then you take 20 mils. You are expecting that it should be 20 mils of water. But it cannot be water because they're going to use it on sperms. Okay, they're going to see. Remember that I've told you that if, let's say, you're doing your sperm count, and then before you say Jack, your dilating fluid is finished. What did I say is a stop gap that you can do? If your reagent gets finished, what can you do?
You can substitute it with water.
With water. But what did I say about the water? I said that, you see, if you have the water, and then remember that you said that in assessing your sperm morphology, if the container that was provided for the patient had even a drop of water, it can cause an abnormality. You remember that. You see, the water now can, you see, the cell membrane, you see, is only semi-permeable as Rhoda wrote on the platform. It's only semi-permeable. It allows certain things, like water. It can allow water to go in. Okay, so once it allows water to go in, and you know that the outside water and then the cell membrane itself, that kind of osmotic activity can take in place there, where water will now move into the cell, not the other way around. Okay, so if there's water in the environment, water in the medium, water will move into the cell. Once water moves into the cell, what will happen is that the what do you call it? The tail will begin to do what? Will begin to swell. The tail will begin to swell. Okay, and that is going to create an abnormality. If you are doing your abnormality check, it's going to create an abnormality. And I tell you that when you are using the water for your sperm count dilution, then the cell must have to be immobilized. Put the specimen between 50 to 60 degrees to immobilize them. Anything that we are, please try and follow the science behind everything that we're doing. And once it comes to its application, you should be able to apply them. Don't say, oh, we did this one and that, when we're doing this one, but it is still applicable here. Okay, so what we are saying here is that if you expose the sperm to water, then there's going to be that in fact, there's something called hypoosmotic testing of the sperm, where the water will now move into the sperm. And once it moves into the sperm, it will swell it. Okay, we don't want that to happen in the sperm viability test. We don't want it to happen because we want the cell to actually be its normal self. So if you want the cell to be in its normal self, what should be the medium? If you want the cell to be in its normal self, what should be the medium? In which hello? The medium in which it should lie.
Is this the line?
Yeah, it should be in saline. It should be in saline, physiological saline. Otherwise, if you put in a reagent that, because we are talking about viability, those that are actually not dead. Okay. So if they are not dead and then you are putting them in a medium that has water in it, of course, every cell, once it is exposed to water will just move into the cell by the action of osmosis. Water will move into the cell. That's very, very simple. So, but we want to avoid that one. Therefore, if you use the using alone in ordinary water, before you could say, Jack, the cells which were actually alive water will cause it to die. The water will move into them and then they will die. And then they all now pick up the stain to become dead. I mean, remember we said that once the cells are picking up the stain, it means that they are dead. But because you use water as a medium, water will move into the cell, kill it, and then now the stain also will stain it, so that everything, all your vitality or viability tests will show positive. You get it. So therefore, the reagent, the using that you are going to prepare should be, the medium of the preparation should be in physiological saline or isotonic saline. So that is it. So you can't use ordinary water to prepare your UOC, because you are going to demonstrate viability or alive or something which is dead or alive. If you use ordinary water, the water will kill it, and then UOC now will also stain it. Then you said, oh, all the sperms are actually dead. You get a concept. That is why you are using saline as your medium for preparing your reagent. Hello? Hello?
Hi.
Are you there with me?
Yes, sir. We are here.
Okay. So before you prepare your reagent, you ought to have prepared your saline. And I'm sure you all know how to prepare saline. What is the concentration of the saline, physiological saline?
0.9%.
All right, good. 0.9. Scientifically, I would prefer 0.85%, even though 0.9% is also correct. But if you are doing any scientific write-up, write 0.85%. Even though 0.9 is not wrong. But if you are doing any scientific write-up, quote 0.85%. Okay? Good. All right. So sperm viability should be assessed as soon as possible after liquefaction of the semen sample, preferably at 30 minutes or within 1 hour. You know why? Because you said again and again that as time elapses, temperature can cause, at the end of the day, we are going to see those who are actually dead. Question is, were they dead from the ejaculate? Because if they are dead from ejaculate, that means that we are going to look at the epididymis and see whether the epididymis, there's a problem there, if they have some infection in the epididymis, or what is in the epididymis that is killing the sperms. Okay. But if you can do that, if you can target the epididymis, then it means that you yourself know that environmentally, you have not caused them to die. Just as we are talking about the fact that your UOC should not be dissolved in water. If you didn't know, you want to ask somebody to give you UOC, which is already prepared. The person prepared the UOC and was not using it for vitality test, but you have prepared it and it's there. You use water to prepare the UOC. Then you just go for it without asking the base of the UOC. Then you are going to kill all your sperms and then report high rate of dead sperms. Okay. All right. So the fact is that you want to be sure that they are dead not from the patient, but they are dead from the outside. If you want to rule out the outside element, then the test must be done as quickly as possible, because if the more they stand, the more likely that they will be affected by the environmental conditions like dehydration and then temperature distance to kill them. Okay, right. The procedure is very, very simple. You go to this one straight away, and then next time you start from the UOC negotiation test itself. So it's just a 1-to-1 ratio of semen to dye mixture. So 1-to-1 ratio is that if you take 1 drop of the specimen, you take 1 drop of your 0.5% UOC. That's all. You place them on the slide, add an equal volume of the saline thin as you said, and mix. Apply the cover slip, and after 30 seconds or up to 2 minutes, not more than 5 minutes, you examine under the microscope using the high power, which is times 40. When you are using the 400 here, the 400 is here is the magnification. The 400 magnification means 40 40 times 40 of the objective, sorry, of the objective, and then the times 10 of the eyepiece. Okay, so don't be confused with the 400 times. That's the magnification. So very, very simple test, and not more than 5 minutes, because as the samples keep longer, then they could dry, and as they dry, the drying could affect the sperm to die. And once they die, then the UOC will not take advantage and stain them and give you a false impression that all the sperm there were dead. Okay. So you identify the sperm which are stained pinkish red or orange red. Those that are stained pinkish red or orange are all dead sperms. While the live ones will remain unstained and appear white in the white in color. So you count about 100 of them because you want a percentage. You want to count about 100 of them to see which one were colorless and which one was colored, and express percentage out of it. And very simple. So this is how you're seeing. So this one is colorless. So of course it is what? Live. This one has that pinkish stain, so it is dead. If you look at those ones here, this is very classical. So this one, what can you describe this one? Dead or alive? This sperm here, is it dead or alive?
It's alive.
Alive. Good. What about this one?
Dead.
Dead.
Good. That's all. So you got it. So the significance of the sperm viability test, the viability outcomes provides a check on the accuracy of the total motility evaluation. So in your estimation, if you do your motility test and then the viability or vitality test, which one of them will you get the same results, or one will go high, one will go low, and which one will go high and which one will go low, if any? Yes, let's get the answer.
One will go high, the other will go low.
Which one will go high?
The vitality.
The vitality, as simple. So now you follow, you understand it. So that's very, very simple. So that is all, and I like it. So God willing, you continue next time, and then we're going to do where you have the nigrosin attached. You work on that one. All right. So very, very thank you for your time, and then I'm hoping that you are following the discussions as you go. And please, if you have any challenge, I want a situation where you will be more empowered, you will have more knowledge and be able to work more effectively and produce the best quality semen analysis report that comes to you. All right. So that brings us to the close of this week. I've said it, and I'm committed to the fact that next week, God willing, we should finish the entirety of the program, and then you look at when to have the practical, if you so wish, and I will do whatever you want me to do. And I'm thinking that the way we are going, we may not even need a practical. But if you want it, I've said it. I'm not going to go back to my word. If you want it, you will have it. You arrange and you have it. If you are okay to then that will be done. Then we give you time to prepare for the final exams, and that will be okay for all of us. I'll always be available to give support if you encounter any challenge in your performance of semen analysis. But you see, look at from where you are coming from. You see, you're coming from very far away. So you have all the sciences and the basic knowledge all behind you to help you already. Okay. So I'm sure that a lot of the cases you'll be able to handle them. All right. And you will even be consultants, because now you are well positioned to understand a lot of the things and be able to provide support for people who are also who haven't gotten the benefit of this program. All right, good. So let's get ourselves prepared to finish it next week. Thank you. I'm done, and good night.